Okay, the first thing I want to do is go over how we will generate the egg geometry, and but before we do that, I want to make sure that you are using Rhino 64-bit and that a few of the settings are correct. So if you key in units on the command line, it should bring up document properties at the units heading, and make sure that you are set to inches, which we are. And then while we're in properties, I want to go down to view, and I want you to open up the tree, and then under display modes, open that up. And depending on what mode you work in, I go between shaded and ghosted, so I'll do both. I want you to select one or the other. So under shaded, I want us to look at back face settings, and the default setting is use front face settings. We want to change that to single color for all back faces. And I usually select something bright, like magenta, so that it's very obvious. And I'll show you why this is important later. And we can go ahead and select ghosted and make the change there as well. So, okay. So now that those things are set up, we're going to start with a circle. We'll put it at the origin point, so I just key in 0, and then it uses the 0, 0, 0 coordinate to start the circle. Diameter will be at 6 inches. Okay, so this gives us a scale which is manageable to be easily scaled for 3D printing and ultimately for CNC machining, though I think the scale may change a little bit. Okay, and once we have our initial circle, I want to create a few construction lines, and once we snap to a point, it gives us a smart line or a smart track that we can then create a construction line with. So I'll do one in the y-axis and then another in the x. Okay, so then we have our x and y. Now we'll come back with another circle. We want our origin to be either on the left or right hand intersection between our x-axis line and the circle, and create that. And the next step is to create a curve, a straight curve from that same intersecting point to the top of the circle. Okay. Once we have that, the next step is to extend this line to the larger of the two circles. So I'm going to actually key in extend, and the first thing it asks us for is select boundary objects. So in this case, that outer circle is our boundary object, spacebar, and then select curve to extend. There we go. Okay, so we're actually getting close. The last circle we need to create will be where that line and the first circle intersects, and this time we're going to use that segment of the diagonal that we just created as our radius, like so. Okay, so now you have actually all of the segments you need to create the egg profile. We just need to trim some things back. So I'll just copy this over so we have it. And there are a few ways to copy. You can either select everything, key in copy, and then click and relocate. Or a quick way is with Gumball active down here, which it is because you can see this sort of device. You can hold the Alt key down and then drag in any direction, and it'll continue to make copies. So we only want one, so I'll select everything, and holding the Alt key, I'll just slide it to the side. Okay, just so we have that initial information if we want it. Now it's really just a series of trims to get to the actual profile. So go ahead and key in trim and spacebar, and the first is to trim at the center point, And I'm going to trim back this circle. The larger circle, so I'm going to trim between this curve and this curve. Okay. And while I'm at it, I'll trim the other side of that circle. And then finally, I'm going to trim the first circle we created. And then after deleting a few lines, you can see what's happening is we have half of an egg. So the next step is, once we have this, there could be several things that we could do. What I'm going to do is revolve the profile to create the volume. So I will just, as it auto-saves, the next thing we're going to do is move this so our bottom point is again at the origin. And then I'm actually, because I'm in top view right now, if we double click on the view indicator, it expands back to 4 views, and then I can go into my perspective view. So in some cases, perspective view is a little easier to manipulate the geometry with, particularly when we're going to start moving into 3 dimensions. So right now it's flat, and what I want to do is bring it vertical. So again, I'm going to use the gumball, so I'm just going to select everything, and you can see there are 3 axes, X, Y, and Z. I'm going to grab the red axis, and you can see it spins around. If I hold the Shift key, it will actually snap to 90 degrees. So in this case, I want this pointing up, which is what we have here. So again, I'll go ahead and move this back to the origin. And we have a few things. We have the profile, and then we have an axis about which it can rotate. So the tool we're going to use is called simply Rotate 3D. So you can key in Rotate, and then it pops up Rotate 3D. Actually, before we do that, you'll notice that these are still individual segments. So what we want to do is go ahead and select all 3, and then key in Join, so that they read as a single curve. And by the way, just going back for a second, if you hold nothing down, you select one object, it deselects the other. If before or after selecting something you hold down the Shift key, you can then add to your selection. So that's what I did. I held the Shift key down, key in Join, and then it's going to join everything that's selected, if it can. So let's go back to Rotate 3D. Okay, so we select the object to be rotated. Okay, enter. Start of rotation axis. Okay, we'll pick the top, the end of the rotation axis, the bottom, and then we can determine how much of the circle we actually want to use. So I'm going to, again, if you can see, it moves along smoothly. If I hold Shift, it snaps to 90-degree angles. So I'm going to pick one angle, and then it's asking for a second reference, so you can see it move around. And if I complete the circle, then you can imagine that's 360 degrees. I'm actually going to go almost all the way to begin with. So let's say we're virtually all the way around. I'm not quite sure why that didn't work. Oh, right. Rather, we're not rotating 3D, we're revolving. So that's later. So we already have, let's start this again. So we're going to select the curve to revolve, which we did, and then the start of revolve axis at the top. Now, again, the mechanics are the same. You snap around and you can swing it. And what I want to do is come close to completing it, but not entirely. Okay? And right now we're looking at the wireframe, so I'm going to go ahead and change this to shaded so we can see what we have. And going back to how I had this set up, I actually set this to show back faces as magenta. And if we go to layer, the layer tab, you see that on the default layer it's set to black, so not magenta. So number one, we know this flip inside out. So if I just type dir, otherwise known as direction, it will show us which direction the normals are facing. And in this case, they're pointing in, which is often an issue. So the simple thing to do is just to click on the object, and it will flip all of the faces so they're facing the opposite direction. And then if we go ahead and hit enter, it solves that problem. So at any rate, the reason I wanted to do this first was to show you one of the important steps in, I'd say, proper model craft, particularly for 3D prints. You cannot have any what they call naked edges. So if I go ahead and key in show edges and select the object, let me grab my little dialog box here. First of all, let's look at just edges in general, right? There are precisely two, and it's actually hard to read, so I'm going to change the edge color to something else. Okay, so you can see that in this surface there are two edges. If we change it to naked edges, there are also two edges. So the goal is to have a watertight volume that has zero naked edges. It's always an indicator that the object is open and potentially could print fine, but more often than not could create a problem. So what we want to do then is to go back, undo this, and under Surface, Revolve, select the profile again, define the rotational axis, and then move all the way around. Okay, so now in this case, if we go back, we want to show edges. You can see there's a single edge, right, under all edges, but then if I change the status to naked edges only, there are none. So another thing that helps us is that when we select this, we see that it, under object type, under the properties tab, it's listed as a closed surface. So these are all good things. That if we go ahead and key in volume, it's giving us a volume of 141 cubic inches. So I mean, as a 3D print, that's massive, but the point is that it's giving us a viable number. I'm going to go ahead and move this off and go back and revolve this again, define that, and I'm going to spin it around. Again, I'm not going to go all the way. Okay, so going back to this, first of all, if I look under the Properties tab, Type, it's reading an open surface, which is a problem. And continue on to run a volume on this. Immediately it says some of these objects you've selected are not closed. So it will give us a number, but it's not really that meaningful if the object's not truly closed. So if we say, yes, I'd like to continue, it does give us a volume, but the reality is in many processing programs, that would be a print failure. It wouldn't successfully process the file. So at any rate, we now have our egg geometry as a surface. So there's one other thing I wanted to talk about, and it should serve you well as you continue to develop the patterning on the surface, and that's converting it to a mesh. So, and this is very easy to do. Under the Mesh menu, you can go select the option from NURBS object and then select the said object. And an option box appears, and there's two ways to do this. One is kind of the very simple way where you say, okay, I want more or less polygons, and we can see if we select preview and then adjust it, hit preview again, the difference in terms of the density. So sliding all the way to the right, we have a volume that has, you know, potentially thousands of faces. If we move it all the way to the left, you know, very few. There's also a series of settings that give you more detailed control over that, including, like, you know, minimum and maximum edge lengths. We're not going to worry about any of that, so I just want to go back to the simple control for now. And we're really going to base this visually on kind of general face size. So I have it somewhere between, you know, the lowest and the middle. And why don't we bump it up just a little bit to give us a little bit more to work with. And let's keep it there. And we hit OK. So it created a mesh volume in the same exact location as the surface. So now when you select this area, you have a choice between surface and mesh. So I'll select the mesh, and again, with my gumball on, I can easily just slide this out of the way. So this is the first step, is to generate the egg geometry and generate both a surface and a mesh solid. And before I go, I just wanted to point out a few key differences. Number one, with the surface, one thing you should know is that under the Properties tab, there is an isocurve density. So effectively, an isocurve is a line that is used to express or visualize the surface. It's not actually a part of the geometry, so it's not part of the calculation. So if I turn it off, this is really what matters. So with with this egg geometry, the only thing that matters is the profile and the understanding that it's been revolved 360 degrees. And if we were to select this and no, not the cage. If we were to look at the mesh, for example, each one of those edges actually has meaning because they're each actually a part of the geometry. So if we were to turn on the control points, each corner of this, each corner of each face is a controllable point. So it gives us, in my mind, more control over how we manipulate the volume. It's also much closer to an STL file, which is really just a triangulated volume. So a few things to keep in mind when you go forward. And from here, the next step is to elaborate on the surface. Okay.